So the next thing that we're going to take a look at is doing a pick-off, bar pull, cut-off operation and talk about how that whole mechanism works. In order for this to work, you have to have a post that is set up with the correct post blocks and has the pick-off, cut-off utility enabled. There are some certain options to do that. My recommendation is that you take the Generic Fanuc 4X MT lathe post and start with that post and customize it if you want to customize a post that uses POCO. Because there are just too many things. I mean, you could certainly take some customized post you already have and go through the process of picking out what you need, but there's a lot of structure that's there with command variables and some other stuff that you have to know about how MP works to get it to work in your post. I know that, for example, this sample part came from one of the students in the class, Josh. I don't think he's here today. But this particular machine is a Mori, and he was trying to get MPL Master to work with his machine. And there were just a couple things that he couldn't really overcome because it wasn't set up the way that our normal generic Fanuc 4X MT lathe post is set up to process the information. And that's really the key. There are what we're talking about here is using pick-off, cut-off. So let's go through it and talk about it as we do it. What I've done is to program this part up to this stage, right? We've turned, roughed and finished the outside. We've done some turning work. We've done some milling work on these slots. Now we're going to come over with our second spindle and we're going to position it over the part. We're going to clamp down. Then we're going to unclamp this chuck over here and we're going to pull some stock out. Then we're going to clamp this chuck. We're going to do a cut-off procedure, and then we're going to retract the second spindle back to a position. Sometimes that's machine home, sometimes that's just a secondary position that you set as a user because you might have 60 inches of travel on this machine, but you want to keep the chucks, 16 inches apart because that's where most of your work occurs. All of these are considerations you kind of have to take into account. But, all right, let's look at pick-off, cut-off. I'm going to save this because we're kind of doing this in stages. In order for pick-off, cut-off to work right from the get-go, you've got to have in your stock setup one piece of stock, either in the left or in the right spindle. You cannot have stock in both. And it's best if you're picking off from the left to the right. There are just more options. For example, we don't support a bar puller on the right spindle, simply because that's just not the way that most machines are set up. If you got a bar puller, it's going to be on the left, and your movable spindle is typically on the right. Okay, we have chuck jaws defined on the left, chuck jaws defined on the right. Okay, and they're both displayed. Right chuck, left chuck, right stock is turned on even though no stock is defined, and that's perfectly okay. My point here is that if you have a machine definition that does not have a right spindle or two pieces of stock defined, one in each chuck, POCO is not going to work. Okay, so here we're starting off and it's in the stock is in the left spindle, and one of the things you can see here on my screen is that the left spindle chuck is shown in a I don't even know what you'd call that, just a bold line, a really thick line, and the right spindle is shown in a thin line. This is basically showing you the active chuck. All right, so once we start cutting over on the right, you'll notice that that one will be a solid color as well. So here what we're going to do is do toolpaths, MISC ops, pick off, pull, cut off. Now before I click on that, let's study this menu for a minute. We have at the top pick off, pull, cut off, which is the POCO utility. POCO is kind of our just our acronym for it, because it's a pain to say pick off, pull, cut off every time. So the POCO utility is a dialog that walks you through creating a series of chuck operations. You can move the chuck, you can open the chuck, you can close the chuck, and you can set options. There are some other MISC ops. We have stock transfer, stock flip, stock advance. These are what are known as standalone operations. So if you do this stock transfer, instead of getting a series of chuck operations, like over here in our ops manager, we have a series of 9 toolpath operations. Pick off, pull, cut off will create a series of tool change, chuck operations, chuck movement operations, cutoff operations if there's a cutoff involved. But basically it generates operations in the operations manager to show the entire process of moving this chuck over, gripping the stock, pulling it out, cutting it off, clamping, unclamping, the whole 9 yards. This stock transfer operation here is a single operation which would be used to do all of the output to bring the sub spindle up, clamp on it, do the cutoff, do all that stuff, and move the sub spindle home. Basically, this is the older style of stock transfer, and it's pretty difficult to use because it doesn't really show you graphically what's going on. It's very cryptic. You go through the stock transfer operation, you set up a bunch of parameters about where the chuck was, where you're going to approach it, how you're going to grip it, how you're going to pull back, how you're going to do all these things. And what you wind up with in the end in Mastercam is the stock's gone over here and it appears over here, and you don't really see anything in between. With pick off, pull, cut off, the POCO utility, you get to watch the entire process and be able to back plot it, which is really key. You know, being able to see where the chuck jaws approach the part, where it grips on, how far it pulls the stock out, where the cutoff operation occurs, that kind of thing. It's really, really nice to be able to do that. And with the pick off, pull, cut off operation, because you're breaking it down into a series of discrete operations, on every chuck operation that's created, you can set your miscellaneous integers and miscellaneous reals to do things like turn on spindle synchronization. You might want to do spindle alignment, so you might want to preset the main spindle to C0 and preset the sub spindle to C60, because you want to clock your part so that when you grip it with your sub spindle, it's in the correct position. You know, there are all kinds of considerations and options that you can do with POCO that's a real pain to try and do with standalone. Okay, stock flip, that'd be the manual stock flip where you're reaching in the machine and flipping the part around. You can certainly configure it for that kind of operation as well. Stock advance, you know, you can do that operation as well if all you want to do is pull the stock. If you want to do a regular bar pull operation, I'd recommend that you just use pick off, pull, cut off and just do a bar pull, because you can do bar pulling without cutoff and without transferring the stock to the spindle with this. So there are all kinds of options here, and we're going to explore a bunch of these throughout the class. So let's get started. Sorry, that was a long-winded way to tell you all about this. We're going to click on pick off, pull, cut off, and what we get is a dialog box that lets us choose what type of operations we're going to program. Pick off, bar pull, cut off. This would be one of the operations where we bring our chuck over, we grab the stock, we pull some stock out, we cut it off, and then the pick off part of it is when we return the sub spindle to some kind of position on the right side and begin programming on the sub. Pick off, cut off just means we're going to go over and grab the part, we're going to cut it off, and we're going to return the sub spindle back to the sub position. You know, there, in other words, there is no bar pull here. Pick off would just be a part transfer. So if you've loaded a piece of stock in your spindle that has already been pre-cut to length, and you just want to program some operations on the left, go over with the sub spindle, pick it up, and return the sub spindle, that's a pick off. Bar pull is just a bar pull operation. So if all you want to do is pull more stock out, maybe you got a parts catcher, and so you're going to program a part complete, and then when you part it, you're going to pull out your parts catcher, and then you're going to do a part off operation. The part's going to fall in your parts catcher, and now you want to come over here and just do a bar pull. You can choose whether or not to retract the spindle after the bar pull, distance to pull the stock. You can do all kinds of stuff here. One of the nice things about using this cutoff bar pull pick-off utility is that the settings that you set for individual operations are remembered between sessions. So if you get used to using 50 inches a minute for your approach speed, and you always want to retract at 200 inches a minute, you don't want to use rapid, and you want to always turn on air blast, you can set up all those kind of defaults and they'll be remembered for you. So let's walk through the process here. We're going to do the whole shebang. We're going to do pick off, bar pull, cut off. First step here is to select geometry. So I'm going to go into the geometry and I'm going to select the whole thing here. Not only am I going to do a copy of the solid, but we're going to do a copy of all the wireframe as well. So I'll select that as the part geometry that I want to translate to the other spindle. I'm going to turn on translate geometry. Translate geometry means I'm going to make a copy of it. I'm going to say I want to copy, actually I'm going to offset all the levels by 1000. So that means all the levels where I had geometry are just all going to be incremented by 1000. We're going to create some views over on the on the pick-off spindle. What this does is create planes for us. All right, we're going to create named view. Instead of pick-off spindle, we're going to call this sub-spindle view. Or how about just sub-spindle? And if we want to, we can be specific. We're going to use this for a work offset or something. Sub-spindle G55. Do we want it on the left face of the part or the right face of the part when this part is now in the sub-spindle? Well, that's up to you. Where are you going to set your origin? How are you going to set your origin? Toolpaths, misc ops, pick off, pull, cut off. What we're doing here is choosing a strategy from the different operations. We can program pick off, bar pull, cut off operations, just pick off, cut off if we don't want to do any stock pulling, simple pick off operation where we're coming over with a piece of stock that's already been cut to length, and we can do bar pull type operations with or without retracting the sub spindle after the bar pull. We're going to start by looking at a pick off, bar pull, cut off operation and how to program that. When you go through the process of setting up one of these POCO operations, some of these choices that you make are remembered from session to session. So if you, for instance, have your machine set up to use spindle air blow to blow out the chucks before you do the operation, and you turn those options on, those defaults will be remembered for next time. So it may seem like a lot of work to set this up initially, but the nice thing is that once you get used to setting it up, a lot of the stuff just comes in preset for you. So first step in programming one of these types of POCO operations is selecting the geometry. So I'm going to select this solid and that wireframe and select end selection here. And I'm going to choose the option to translate geometry. We're going to choose to translate this and offset it by 1000. All right, so now we're going to say we're going to translate the geometry. We're going to offset all of the geometry's levels by 1000. Basically, it's going to make copies of everything that are offset by increments of 1000. We're going to tell it we want to create a new plane, a new view for our sub-spindle. And in this case, we're going to use this to set a work offset. We can choose whether we want this generated plane to be on the face of the chuck that is now pressed against the sub spindle or some stop, or whether we want it to be on the left face of the part. Depends on how you set your machine. We generally want to tell it to generate pick off spindle stock. because this is going to create a piece of stock, lathe stock, like we see over here. And that stock can then be used for stock recognition for your lathe turning operations on the sub-spindle. Now we need to supply some information to the utility. What's the length of our finished part? We can select from geometry, but that's going to include all the geometry here. What we may want to do is actually go back and click on the geometry button and just grab the solid. Okay, and if we do that and then say from geometry, oh, it did pick that up. Okay. Well, hopefully that is the length of the finished part. We'll find out in a bit. Pick off Z coordinate. This is the point on your part where the chuck jaws are going to come grab the part. So generally what I do is use the little arrow button to pick up a point off the geometry. We may want to grab the part here. We may want to go all the way up against this shoulder. I'm just going to pick right here. And that measures from the origin, gives me the point that it's going to grab my part. Now we need to give it the cutoff width because we're doing a pick off bar pull cutoff. One of the things that we can do is use this tool button to select the tool that we're going to use to perform the cutoff operation. So this is a nice feature because once you set up your tools to do the grooving and parting, it'll be all set for you. Filter. Now, one of the things you have to be careful of here is what tool you're grabbing, right? Whether it's in the top or the bottom turret. You notice all of these here are bottom turret. We may have to play with the tool and reset it up by the time we use it. Again, grooving parting tools, something 125 narrow. Now if I right click on this, first thing I'm going to do is grab this tool and copy it up into the library, or copy it up from the library into my part tools. Then I might edit the tool. Let's make this tool 6. If we do setup tool, yeah, we want to make sure top turret, it's vertical, left spindle, draw tool. You notice here if we draw the tool, it's shown in a horizontal view. That's not good. Oh, it's probably because I was editing the wrong tool. If I do grab the tool, it's going to give me the cutoff width. So I selected the tool, I think 4141, it gave me the cutoff width. Cutoff X coordinate. If we choose from stock, it can read our stock definition and it can position it. In this case, we don't have any extra stock on the part. So what we're going to do is just supply it. Basically, this is where do we want to start our cutoff operation from. Let's do a 1.25. Face and back face stock. Do we want to leave any stock here? Let's leave 50 thou on either side. We've gone through and programmed this section. Now we can go and click on operation. What this operations tab shows you is the series of operations in the order that they're going to be created. So if we click on pre-position cutoff tool, every time we click on one of these options, this has all of the options for each of these operations that we can set. So if we go to pre-position cutoff tool, this means we're going to take our cutoff tool, we're going to rotate to the cutoff tool on the turret, and we're going to move the cutoff tool into position in between the chucks. So where do we want it in X? Let's put it at 4 inches in X. Let's get it out of the way of our chucks. We can use any value here, but depending on how we have our tools set up, if we get it too close to one of the chucks, then it's going to warn us, okay? Or it's going to try and crash into it. Pre-position Z coordinate. If I click on equals Z cutoff, you notice what we get here? It automatically knows, based on the amount of stock that we're leaving and the length of the part, where to put the tool so that after we do our bar pull, it's in the right position to cut it off. We can also give it our own position if we're not satisfied with that. So if we want to type in a position, we can do that as well. Pick off spindle. So what's going to happen here is over on the sub spindle, we're going to unclamp and eject the part. We can set a comment. We can tell it not to post-process the operation if we really don't want this to come out in the code. And for this particular operation, we can set custom parameters. What would we want to set here? Some of the default options that we have are reposition mode, whether we're in rapid or feed rate, clamp, unclamp, dwell time for the chuck, feed rate amount. So if we're in feed mode instead of rapid, what do we want our feed rate to be? All the rest of these miscellaneous integers and miscellaneous real numbers are available to us. So at this stage in the sequence of operations we're performing, if we want to turn on some options, say we want to turn on like M288 or something, and that is gonna rotate both chucks for 3 seconds to spin off coolant or chips or something, and then we want to do M416 because it activates some sequence on our machine. That was what we would set these miscellaneous integers and miscellaneous real numbers up to do, and that's what we're going to do during class. So all of these operations have custom miscellaneous parameters that we can enable or disable. So now we're going to go, so first step is unclamp and eject the part. So if there was any stock in the secondary spindle and sub spindle, we would eject it. And now we're going to move the spindle to the clearance distance. So in this case, we're going to say, I want my approach distance to be 0.75. I want to rapid to this position. So in my custom parameters, I'm going to make sure I'm in rapid. So reposition mode 0 is rapid. Now it's pick off spindle, move to grip position. So after we've gone to the clearance distance, this is going to be moving us into the grip position. I'm going to go custom parameters, feed rate, so we're going to hit 1, and feed rate amount is going to be, say, 35 inches a minute, whatever value you want. Now we go to pick off spindle clamp, and I'm going to go into custom parameters and say I want this to dwell for 1.5 seconds. So I'll put in a dwell amount. Now we go stock spindle unclamp. And you know what? Here I want to dwell, but I only want to dwell for a half second because my unclamp's way faster, or for some reason like that. Now we're going to go pick off spindle pull stock. Okay, so again, this is a stock pull operation. We're going to do it at feed rate, and we're going to say we want this to pull at 60 inches a minute. Stock spindle clamp. So now my main spindle, since it was unclamped for the pull operation, is going to clamp. And once again, I'm going to dwell, this time for 2 seconds. Now we're going to cut off the part. Okay, so this is showing us from our operations library, lathe-inch.operation7. It's got this cutoff tool, and we can either select our own tool, or we can use a tool from the operation. So if we want to grab a custom operation, you can have an operations library already pre-set up with multiple cutoff operations, and you just grab the operation you want. Okay, so we've got a bunch of different options that we can use here. It's kind of up to you as to what you want to do. So if I say I want tool 4141, I want to use that tool, I'm going to do that. Now I'm going to go pick off spindle retract. When we finally pull the spindle back, what do we want to do here? Let's go custom parameters and say, all right, I want this to be at rapid, so I'm going to leave it at 0. Or maybe I don't. Maybe I want it to be at feed, and I want that feed rate amount to be 200 inches a minute or something. The point here is you can see the series of operations you're about to create, and you can set up all the operations parameters that are important, and all of these values get remembered the next time you run this interface. So I'll select OK, and now the magic happens. Oh, did I get caught here? Oh, I got caught. All right, hold on. So I tried to mix too much stuff in there. So I tried to have it go and draw the tool. I shouldn't have done that. So I'm going to go back in. We're going to run POCO again. Give me 1 sec here. Okay. Let's try this one more time. We're going to do toolpaths, misc ops, pick off, pull, cut off. I'm going to select the geometry, in this case my solid. Say translate the geometry, offset by 1000. Length of the finished part, I'm going to click on from geometry, so it's going to interrogate the solid. Pick off coordinate, we'll pick off from there. And we're going to leave some stock on either face. Going to grab the tool, gives me the 125, X cutoff coordinate, we're going to do 1.25. And then in the operations, we're going to set up these values here. So move to clearance distance, we're going to give it the clearance distance 0.75. We're going to do that at rapid. Move to grip position is going to be done at feed. Clamp, we want to dwell. Unclamp the main spindle. We're going to dwell again. Pulling the stock. We're going to do that at 60 inches a minute. Clamping. Let's clamp again. Cut off the part. We've got a tool selected. And pick off spindle retract. We're going to do that at feed, but it's going to be at 200 inches a minute. Okay. Click OK. And what happens is we generate all those operations. So here, with the arrow at the end, is after all of those ops have completed. If we go in and select all these operations and do backplot, oh, hold on. I'm going to grab the arrow, bring it up to the top here, and now we're going to go to backplot. So what happens is we start stepping through here. We position our cutoff tool. In this case, the tool's on the bottom because it's set up for the bottom turret. I'm going to go in and fix that. So here you notice what we created was a lathe point operation to pre-position the tool. We have a lathe chuck operation, a lathe chuck, lathe chuck, lathe chuck, lathe chuck, lathe chuck, lathe chuck, a lathe cutoff, and a lathe chuck operation here. If I just leave all this as is here and start trying to modify my tool, it's probably going to screw me up here. So what I'm going to do is just select all these operations and delete them. Let's delete all that geometry over there. And we're going to delete that group as well. I'll save that. And we're going to run this again. Before I do that, what do I got here that's going to be a problem? Anybody see it on my screen? I got something that's going to give me a problem if I try to run pick off cutoff. Stock and sub, right? Stock, yes, correct. So I'm going to go back to stock setup, right spindle, click on the radio button here, and then delete. Oh, I did not want to do that. Hold on, I'm going to grab this. I deleted the wrong thing. Sorry about that. I want to delete the stock, not the chuck. Important difference. Right spindle stock, delete. There we go. Okay, save that. Now let's go through and do pick off, cut off again. Pick off, pull, cut off. Now look what happened when we came back in here. It remembered the settings that we had last time. So we are going to do geometry, that guy. Yes, we are going to translate the geometry. We're not going to create a named view because we already should have one. We are going to generate the pick off spindle stock. All this stuff stays set up the same. Before we get into this though, we do want to do one thing. Sorry about this. We want to go fix our lathe tool. So we want to take this tool right here, right click and say setup tool. This is going to be on the top turret. It's a vertical tool. It's on the left spindle. Okay, and right now we're going counterclockwise. If I go clockwise, you notice that it changes it. So I also want to do draw tool. Okay, so this is the tool that we're using. It's now set up the correct way. So we can do tool paths, mix, ops, pick off, pull, cut off. Make sure we're on the bar pull. Okay, pre-position, that's all still set. Unclamp and eject parts, this is set. So remember how when I first did this and it didn't generate, I didn't get any of these things saved? That was because it didn't, I was trying to draw tool and do a bunch of stuff in the background. Once you go through and run this, it remembers all your settings, which is really handy because then I don't have to go in and fill this out every time, right? It remembered all that stuff and I just make sure I'm set up to do it right and I hit OK and it does everything for me. So here's all my pick off, cut off operations. Let's backplot them. Okay, and what you see is it starts out and it pre-positions the cutoff tool. Where are these values saved? There is an XML file that gets saved as part of the pick off, cut off process. I'm not exactly sure. I can't remember if it's a .transfer file or if we do something else with it. I'll have to ask Michael because I'm not exactly sure. What I was told was don't worry about it because you don't really, it's really hard to understand and you can't edit it. So I don't know if that's true or not. I'll have to do some digging around to find out, and I'm not sure if you can even have multiple of them. So if you have more than one, it might screw it up. You notice there is no real option on the interface to select a custom one. When you go in and you run pick off, pull, cut off, you only get like no operations, pick off, bar pull, cut off, pick off, cut off, pick off, bar pull. So as far, you may be able to have multiple .transfer operations files and like swap them out of the directory before you start this up, but I'm not sure. I know, like, for example, if you do the cutoff, you can come in here and you can have a library of cutoff operations. So that may get you what you need if all you want to do is be able to swap out the tool on the fly and the position of the tool, something like that. I don't know. But yeah, again, I'll have to find out. So here we'll do backplot again. I'll hit step one time. Oh, hold on. I'm going to move the arrow to the end of these operations here, and we'll do backplot. So the first thing that we do is we position the cutoff tool. And what you have to be aware of is there are some things that you'll see in backplot that won't happen on the machine. So for example, with this point operation, the way that these operations are written in the NCI file, we would have a position to go to the point operation, and then it would have a retract back to the home position. We go into the post and we suppress that retract. And what that allows you to do is it says, oh, we're in the middle of the pick off cutoff. We just positioned this cutoff tool here. We don't want to let the tool retract. We want the tool to stay there, and we want to let the chuck come in and approach the part and do all the moves. So just be aware of this. This is really important, that you may see some things that happen in backplot, and you're going to have to check the code and realize that, okay, that retract that we saw was suppressed. Okay, so I'll step again. So like that retract, by the way, that didn't happen. Let's see, come on. Okay, so we're gonna try this again. Go into back plot, step, that brings our tool over. Okay, now at this point, what we need to pay attention to is the chucks and the stock and not worry about the solids, because the solids are independent of what's really going on here. At this point, we have unclamped this chuck over here, and this one is clamped. Now we hit step again. And notice that we've now gone to our approach distance. Okay, hit step again, and now we go to our grip point, hit step, and we've clamped onto the part. We've unclamped the main spindle. Now we pull our stock. Okay, so we've pulled our stock out. You notice that we're showing this tool reapproaching here. This tool never had to reapproach. It was there the whole time. But there's just some limitations in backplot. So now we come to our start of our point operation. Why? Because we told it to go all the way up here. I told it something like 1.25 for the point that we wanted to part from. I could have given it a point down here, but I wanted to make sure we had enough clearance. So now and these are all things that can be adjusted, of course. So I've fed into the part, I've done my cutoff, now it's going to retract, now the tool is going to go home. Okay, and the final thing that happens even though it's not quite showing it right, the final thing that happens is the retract. Okay, so where did it retract to? Anybody got a guess? It's a good guess, Corey. Right chuck position, yes. And the right chuck position is defined in stock setup. So when we define our right spindle here, this is the place that it's going to retract to. So you just be aware of that. If we got a machine, we got 60 inches of travel, but we're working on a real small part, we may want to set it up so that, here, if I look, that's where it retracted to. So it retracts based on the setup values that we've got. Now, we can certainly set this up as far as programming a pick-off, cut-off sequence of events. We can certainly set this up to allow you to output an override position if you want for your sub-spindle axis. And it depends. Some machines it's a B axis, some it's a W. For some it's C2B or something like that. Whenever you're programming the C operations, they're C2, and then driving this axis here is B. So it just depends. So let's look at what we output if we just post this out right now. Okay. Hold on a second. Let's make sure. And let's close that. Okay, so these are our lathe operations. There's the bull end mill cut. Here we are pre-positioning our cutoff tool. Let's blow this up a little bit. So here we're pre-positioning our cutoff tool. We're moving it into position. Now we're doing pick off spindle, unclamp, and eject part. So you notice we're getting our M210. We're getting our dwell value. Now we are pick off spindle, move to clearance distance. So here we're rapiding to B.75. Then we're going pick off spindle, move to grip position. So G1, B minus 0.617, F35. That's what we told it. Clamp, and we're getting our dwell. Unclamp for the main spindle, we're getting our dwell. Now we do our pull stock. So we're positioning B to 0.6253 at 60 inches a minute. Now we're clamping and dwelling. Now we're doing a cutoff. So now we're enabling our cutoff tool. We're rapiding to our diameter position. Even though we told it a radius, it goes to a diameter output. Now we feed in, feed to the center, feed back out a little bit, and then wrap it back out, and then wrap into our safe position, and then go home. And then finally, we retract the spindle to our B 8-inch position. And again, that position came from right here. So, what post blocks does it use? Let's take a look at that. Is there a way to home the cutoff after sub return? Sure. Yeah, we can override kind of all of this stuff, Corey, which is some of the things that we'll be doing. So let me go back in there. Let's repost that real quick so we can look at the code. I think I closed it. Oh, yeah, I was in Code Expert. So what we've done here is we've retract, we've finished the cutting here. That's the retract point, and also the start point, I believe. And then we've got this home move for the tool. This comes from PL retract and P tool end. So what we need to do is save or suppress that retract until after POCO is over. So how do we know when POCO is over? Well, that's something that we have to add to the post to be able to find out. So the place where a lot of this processing occurs starts down here in a section called V9 plus MISC ops section. Okay, and there are a bunch of variables that are initialized that get used as far as chuck, start and end positions, final positions, tool clearance, all kinds of stuff. And we have P stock transfer, which is that individual stock transfer op here. P stock flip, which is the 901 code. So NCIG code 901 is generated from stock flip here. Stock advance, any guesses on what the G code might be? If this is 900, this is 901. Any guesses? If you guess 902, you're right. So stock advance bar stock feed is 902, and P chuck is 903. So the thing about this that makes the Poco so much more powerful than just the standalone operation is that instead of one operation, you've now got one, the point operation, I guess we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 operations that get processed in order. And the important part there is the in order. Because we're writing multiple NCI 903 codes, the order in which we process them means the order in which we're going to hit here, which means that we can set individual options in each of these miscellaneous integers and miscellaneous real numbers section. And by doing that, by having control over those misc ops, we can do anything. Any kind of motion that you want it to perform or any kind of code that you want it to output during this sequence of events, we can do. Okay, so these are the ones. I want you to look over these post blocks on your own. I want you to look through and just kind of read through and look and see what it's doing and see if you can guess about maybe some of the things that are happening. We're going to look through this all in depth together and modify a bunch of these options. But this is really where the magic starts to happen, is in P chuck. So, what were we talking about? We were talking about, is there a way to home the cutoff after the sub return? Yes. Where we're looking at is a post block called P tool end. So P tool end gets called at the end of every tool change event. And based on the settings, we're going to end up calling either PL retract or PM retract. In PL retract, this is where we're getting our home position. And so what we're going to need to end up doing is setting some flag variables. And a flag variable is just a numeric variable that you use to indicate a state. And with that state, we're gonna determine, are we in a series of pick-off cutoff operations, or have those pick-off cutoff operations ended? We got a question from Tony about P chuck. And he says, why is there a call to P header? There's a call to P header in case you want to start off your programming with Poco and then do some cutting operations. So if you want to start by going and grabbing some stock, pulling it out, doing a cutoff, and then maybe you're going to turn on both spindles or something like that, it allows it to process and to include the header beforehand. Now, if you go and you look at P header, you'll see that the entire P header post block is wrapped in an if condition. If misc op flag equals 0. So what you can see is that if we go into misc ops and misc op flag is equal to 0, it will allow you to output the header from the first instance of the call to P chuck. Because you'll notice at the end here, misc op flag equals 1. Okay, so we've got some stuff in there, and then if we look at like misc op flag, you'll see that the call to P comment is from manual entry, and so it says if misc op flag equals 0, call P header. Okay, so anyway, it's a way that we can get header output if we're using POCO as the first operation. So back to P-Chuck, we can use conditions in here to determine when we allow retracts and when we don't. And a lot of the times what we're doing is basing this off of the variable tool op. Okay, so tool op tells you specifically what type of operation we're processing, whether it's a chuck operation or a lathe finish or a point or a cutoff or what we're doing with it. And the tool op codes for chuck operation is like 215 or something like that. Anyway, we can use some code to suppress that call to send the tool home before we've finished the chuck operation. Now, if we look at the structure of the NCI, there is an NCI line that's really important. And it's going to be written for every operation as it's processed. And that line is NCI line 999. So we're going to go look that up in the documentation. And we're going to go to the X7 NCI and parameter reference. Make sure this gets in the window here. Oh, actually, I'll just go to NCI G codes. And we want 999. NCI G code 999 is the start of operation code. It's what lets MP know that we are now processing a new operation. There are 3 variables on the data line for the NCI 999. The first one is sync tool op, which takes the same value as tool op, but allows you to access that value earlier in the NCI read loop. So SYNCTOOL_OP grabs the same values as tool op, and tool op's a very important one. We have our sync stream value in case we're writing out multiple streams of data. We know which stream we're writing or which stream we're reading from. And then we have the op ID, which is normally read from the 1016 line, but now we can take the same value from op ID and it gets copied to sync op ID. And this allows us to have these tool op and op ID values at the very, very start of the operation, which is pretty important. Okay, so sync tool op and sync op ID can be read right at the start. Now, when we're looking here at those 999 codes, by the way, 999 calls in the post thought we had a sync in here. Guess not. Let me Might not be used in this particular post, but pretty sure I know a post where it is. Oh, that's called by the 950. Sorry, I thought it was called by P999. But anyway, if we look back at P-Chuck, there is an undocumented post block that we can use that makes our life a whole lot easier when we're processing pick-off, cut-off operations. That post block is P miscop underscore $999. P miscop underscore 999 is a post block that gets called at the start of every POCO event. So anything in here that was generated as part of pick off cutoff, P miscop 999 will get called before the start of this op, this op, this op, this op, this op, this, and this. So the important thing here is to show what happens and how we can use that as a flag. So let's do this. Let's start another group. Call it sub. And back here on the sub spindle, okay, now we got some geometry, tool paths, lathe tool manager, and we're going to get let's see. Set my delay there, and we're going to edit tools, setup tool, top turret. It's going to be a vertical tool, right spindle. Again, if we're on the wrong hand, we need to go in there and flip holders. That looks right. Draw tool. That looks right. Okay, so we've set up our tool. Now we're going to do tool paths, rough, and oh, sorry, before we do that as well, save that, and we're going to go view manager. Okay, so now what I've done is switched my tool and construction plane to my sub spindle G55. If we go back into view manager You'll notice that it's basically at the back point of my chuck. So if I want to change the origin here, I can. You know, maybe I want it to be off the face of the part. Oh. That's not what I want. Okay, I got that set. So we're going to do a rough toolpath. Yeah, we're going to go there. Now, what's the first thing I need to do in here? It's a pop quiz test. Yep. Axis combo. Axis combo. Okay, make sure that you've got the right axis combination set up. And I'm going to turn off Show Library Tools. And there's my tool 0404 that I set up. And so now that I've got right up, or I right click on it and I do Edit Tool. Okay, Draw Tool, set up right. If I go Setup Tool, right spindle, counterclockwise, top turret, vertical, the inserts facing the right way, the draw tools facing the right way, I'm good to go. Now I go rough parameters, and choose the direction that we cut. We don't want to cut up and down, we want to cut left and right. So that's what we're doing here. So cutting method one way. Oh. What do we do here? Let's go disable stock recognition. Whoa. Well, that's a little funky. Wonder what I gave it for my geometry. Huh. That's not right. Left. How about no roll around cutters? Reverse chain for OD routine. Oh, for this? Really doesn't seem to want to do that very well, does it? Try changing sides, and let's make sure that that's on right. That looks good there. Well, that's interesting. All right, I can buy that. Oh, and you know what? We also probably got to adjust as our plunge parameters. Yeah. All right. We at least got some cutting on the right spindle. We can figure that out later. What I want to show you guys, because we're trying to wrap up class, is pmiscop_999. And what I'm going to do is copy that after regen. Okay, so now we got a couple operations on the sub spindle. We got a bunch of operations on the main spindle. And what we're going to do here is in pmiscop999, okay, we're just going to output this statement. And then we're just going to repost this. All right. That real quick, and let's repost this. So as we look through, there's first op, second op, third, fourth, whatever. Come down here. And what you can see is that we have our lathe point operation. So the pre-position is not included in the miscop 999. Okay? So there's no debug from there. But if we use some next variables like next op ID or next tool op, we can get some of those values to know what's coming next. But here we've got the ability to set a flag here to say, all right, we've started processing POCO. And now this is all POCO, 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 cut off the part, POCO, and then you notice that this debug output from pmiscop 999 happens before the retract here. So we can use that in order for us to set a flag to suppress the call to p tool end, which is going to send your tool home. And then after this is, after that's all done, then after we move the spindle here, we can say, all right, in p chuck, we can basically look and see if we're at the next tool op, and then we'll add some code at the end here that says, all right, if the next tool, if the next tool that we're doing is not a chuck or a point or a cutoff operation, and a flag is set, then call p tool end. And so the call to p tool end, what we'll end up doing is setting a tool end flag and making a call to p tool end, which will output the retract. So we're going to do that as an example. One of these nights, probably not this coming office hours, but maybe the next office hours after that. So we can we can look at doing all these little tips and tricks and making pick off, cut off work for us, making it do what we need it to do to run the machine. So questions about what we've talked about so far in class? I know a lot of this is just kind of like, wow, he threw a whole bunch of stuff at me. I'm not even sure what to do with it yet. And that's okay, because we're going to be going through this together and looking at how do we use the tools that are in MP and in the language to customize the code to give us the output that we need for our machine. Why is P-MISC op 999? Michael, it's P-MISC op. There's no S on it. Why is it undocumented? Because it's new. We have plans to document it, and part of the reason that we haven't is that we are currently going through the Generic Fanuc 4X MT lathe post, and we've got a project to add some default post blocks for spindle synchronization and spindle alignment, because those are two requests we get a lot of. And just documenting P-MISC op 999 alone doesn't really get us much unless we add something and show how you can use it and do something with it. So it's not that we don't intend to, because we certainly do intend to document that. It's just, you know, one of those things that we haven't gotten to quite yet. I think it works in X6. Don't quote me on that, but I'm pretty sure it works in X6. X5 only contained Poco as a prototype, so unless you had a license to run it, and mostly it was only developers that did, you're not gonna get anything from that. So I think X6 is the first version you can use the P-MISC op _ 999. Good question, though. Yeah, absolutely. Thanks, Michael. Any other questions before we wrap it up for tonight? Okay. Well, I think that's it for tonight. Thanks, everybody, for attending, and we'll pick it up for office hours on Wednesday this week, and then we'll come back and we'll start talking more about configuring pick-off, cut-off, and setting up our machine for a Mori. Thanks, everybody. Gonna wrap it up.